As I'm walking through Devils Canyon here, we notice this red rock, and it's kind of light for its size. And the reason why is because this represents very hot lava. I mean, like I said before, the lava in this canyon, most of it, came from southeastern Washington, northeastern Oregon, where the earth opened up and all the lava, it flowed this way, and we call this basalt. However, in this one precise location, we are finding this red rock. Now, when you find red lava rock, that means it got very hot. And so we got to ask this question: why did it get hot in this precise location and we don't find it anywhere else? Well, maybe it could be that when all this lava was flowing through here, a volcano rose up. This is representative of volcanic action. So it could be that as the lava was flowing through here, a volcano actually started blowing up in this area, and that's why this rock is so red, and that represents a lot of heat. See, here is a red rock. This is basalt, but most likely this came from a volcano right in this area. And we find a lot of red rock up in there, and but it's just right here. It's just amazing to me that we would find this right here. We don't find it across the canyon over there, but we find it right here. Devils Canyon is a really cool canyon. The Missoula flood, that is a result of the Ice Age, which is a result of Noah's flood, came through here, carved out this huge canyon, and exposed these rosette-looking columnar basalt flows. Columnar basalt flows tell us that the lava cooled really fast, and we have evidence that this was all underwater at one time, and that's why it cooled so fast, because the salt water of Noah's flood, and now we don't know how salty the water was, but we know that the chemicals in the basalt reacted with the sodium chloride that was in the flood waters that covered all of this basalt when it was flowing. And so somehow this basalt flow cooled so fast that it created this columnar joining that we find here in Devils Canyon. Here we are about 15 miles north of Pasco, Washington. And you'll notice behind me is what we call a rosetta, but it is columnar joining. And you'll notice there's this crack that runs right through here. And you've got pillars that are running off to the left of the crack, and then you've got pillars that are running off to the right of the crack. And so they're going like this, which is really cool. Now, the question is what caused that? Why did those pillars start to bend that way and these other pillars bend that way? Well, one of the really good theories is that this is evidence of rapid cooling. And so, rapid cooling based on what? Well, this flowed underwater. And the water is what caused it to cool very rapidly. And water got through these cracks here. And as a result, it created these columns that could be like 4-sided or 6-sided or 5-sided. And then on the other side, we have the same thing, except we have columnar pillars that are at a U, which is really amazing. So at one time in the past, water flowed through here, carved out this little canyon, and exposed this, and then exposed what is in front of me right here. Here we're looking at this Rosetta columnar joining, and you'll notice that there is yellow powder, which is called palagonite. That palagonite that is in that columnar joining is proof positive that this all flowed underwater. Because when the lava flowed in the water, it flashed a steam, creating that yellow powder.